So let's do some calculus, shall we? I started off with the graphs that I did on one of the first lectures, and this is just a reminder then. So for velocity, using my graphs, velocity then, the integral of a velocity function, that's here, is going to give me my delta x, my displacement, and the derivative, so d by dv of velocity is going to give me my acceleration. And over here, then I have acceleration. I can remind myself I looked at the slope, that's the jerk, we're not going to use that. And I suppose we could. But the acceleration then is, or I'm sorry, the acceleration thing that is going to help us, my brain just stopped, is going to be the integral under the curve, or the area under the curve, which is the integral. So the integral of acceleration is going to give me velocity. And then the slope of position or displacement, remind ourselves, gives us velocity. So the derivative of position will give us velocity. And the integral of acceleration gives me velocity. Or I can look at velocity, just kind of gives me everything. I can go the area under the curve, I can integrate to get my position, or I can take the derivative of it to get my acceleration. So the first question here is saying, okay, I'm giving you this equation that's describing its velocity. We want its acceleration and we want its position. So for acceleration, I look at my velocity, and I'm like, okay, so I need to take the derivative of this function. So d by dt of 3t squared plus 2t plus 5. Let's see what that's going to give me. Remember, I'm going to pull the 2 down, so that's going to give me 6 times t. This 2 minus 1 just gives me a 1, so that stays the same. And then plus, well, this t here has just a 1, and so nothing comes down, just 1 times 2. And then 1 minus 1 is 0, so the t goes away, so it's just 2. And the derivative of a constant, well, something that is constant is just a line. There is no slope, it's 0, so there is no derivative. Now I can answer the question. So at t equals 3 seconds, I have 6 times 3 plus 2. That gives me 18 plus 2 is 20 meters per second squared. So I have to do this when I don't have a constant acceleration. If the derivative of velocity exists, then I have acceleration for it. So in other words, I have that slope, I have some sort of changing acceleration, I have to do 20 meter, I have to do the derivative in order to get that, because this is going to be different for whatever time I do. Let's try it for time t equals 2. At t equals 2, I have 6 times 2 plus 2, otherwise known as 12 plus 2, 14 meters per second squared. So my acceleration is indeed changing. I cannot use the equations of motion because those are for constant acceleration. So if the acceleration is changing, you can't do it. You can't use the equations of motion that we're using in the previous. So now the next question is, well, what about x of t? Let's do that in a different color. So I look at this. To get my displacement, I need to do the integral of this function. So I am going to go like this, the integral of 3t squared plus 2t plus 5 dt. So I'm looking at these changes with respect to time. Now when I look at this, I need to keep in mind, because I know that this is still new to some of you, that integral is going to carry over to each and every piece. So that's going to be an integral, that's going to be an integral, that's going to be an integral. So the other way to write this is going to be the integral, and we'll pull the constants outside so they're not in the way, of t squared dt plus the integral of, oops, I want to pull the constant out, of 2t dt plus the integral of 5 dt. So remember, with integrals, we're adding 1, and we need to make sure that we get the same thing back as when we started. So I'm going to add 1 to the exponent, and I'll start with the first integral. So I have 3 times, let's see, t cubed. So do I need to divide by 3? Let's just go ahead and get in the habit of doing that. I divide by 3, that's going to make that 3 cancel out. So I'm left with just t cubed. And now let's see, if I take the derivative of that, what do I get? So d by dt of this is going to give me, let's see, the 3 will come down from the exponent, take 1 away from that, 3t squared. So that is indeed the same thing we started with. So that is that one piece. Just making some room here. So let's go ahead and do that. I have then t cubed is going to be my first expression. Now I'm going to do it again for this. So plus, well, what's this going to become? That's going to become t squared. I'm adding 1 to the exponent. And what happens there? If I pull the 2 down and divide by the exponent, that 2 is going to cancel out with that 2. So again, I'm left with just 1 in front. And then I come over to my last one here. Well, there is nothing there, so that's the equivalent of t to the 0. So that's going to become t to the 1. And I can divide by 1, but 1 times anything is just 1. And now here we have limits. So we're evaluating from t equals 0 to t equals 3 is what we're actually evaluating at. Notice that t equals 0, it's 0. So remember, that means that I'm going to have, starting at the top, I'll have 3 cubed plus 3 squared plus 3. I just want to be explicit about this, minus the 0 goes into each of these. So I'll have 0 cubed plus 0 squared plus 0. Not necessary. I know that that equals 0, but I just wanted to show you why we tend to just ignore that, because it's just 0. So let's see, I have 27 plus 9 plus 3. Whatever the heck that is, that's 12. So 19, whoops, 19, carry the 1, 4. So 49. What did I just solve for? That's 49 meters. So my final answer for the distance I've gone in 3 seconds is 49 meters.